Hello everyone. Today let's solve the problem number 268, missing number. So what the question states here, we are given an array nums. You can clearly see here we are given an array nums containing n distinct numbers. So all the numbers are distinct, they have said, in the range 0 to n. So exactly one number in this range is missing from the array. So they have said exactly one number is missing from the range. So our task is to find and return that missing number. So in this case, the smallest number is 0 and the largest number is 3. Means this is 0 to n we have here on this case, right? 0 to n means here 0 is 0, n is 3 in this case. So we have 0, we have to check whether all the numbers are present. One number will be missing, right? 0, 1, we don't have 2 here, right? So this is of the range 0 to 3. Smallest number is 0 and the largest number is 3. So this is of the range 3, and we have to count from 0 to 3. Basically 0, 1, 3 we have. And what about 2? 2 we don't have here. So 2 is the missing number and we will return that 2 here as output, right? Let's come to the same here. Let's come to the second example here. We have 0, 1 here, right? So missing number, 0, it starts from 0 and the n is basically 1, right? So the range is basically 2, right? So the range is 2 here in this case. So we don't have 2, so we'll be adding 2 in this case, right? We don't have 2, we'll be adding 2 in this case. So I'll just come here. So since there are two numbers, so all the numbers are in the range 0, 2. 2 is missing in this range since it does not appear in the num. So that's what they have given here, right? So here as well, 0 to 3 means 0, 1, 2, 3. The range is 4. So we have only 3 numbers here, 0, 1, 3. So we one number is missing, nothing but 2 here, right? So that is how we calculate. So here in this case, range is 0, 1, 2, 3. It starts from 0, right? 0, 1, 2, 3, 4, 5. This one 0 to 8 we have, basically, right? 0 to 8 we have, means total numbers are 9. 0 to 8, when I say total numbers should be 9 basically. So here one number is missing, nothing but we have 0, 1, 2, 3, 4, 5, 6, 7 and 9. 8 is missing here in this case. 8 we will return. So n is 9, means 0 to 8 we have n is 9. Since there are 9 numbers, so all the numbers are in the range 0, 9. So 8 is the missing number in the range since it does not appear in the number. So that's what they have given here. So we have to return the 8 as output here. So easy to understand, right? So I hope the question is completely clear. I hope the examples that we discussed is completely clear as well. They have given us wonderful examples just for the sake of understanding, right? So let's discuss the approach first and then let's write the code and discuss the complexities for the code that we have written, right? First, let's discuss the approach. So here I have considered the same first example that they have given in the question here so that it will be easier to understand. So we have 0, 1, 3 and which is of the range 0, 3 here in this case, right? So the missing number we have to count. So the number should be 0, 1, 2 and 3. We have 0, 1, 3, 0, 1 means 0, 1, 3. So 2 is the missing number. We need to return 2 as output. So that is how we got the output 2 here. So we know this. We have already discussed this one. Let's go with a step-by-step explanation here. Same example. So nums equals 3, 0, 1. Let's initialize the XOR equals n equals 3. So we will be going with the XOR operation. So here I forgot to say. So we will be going with the XOR based index value cancellation. XOR based index value cancellation. We'll be going with the XOR, right? XOR, just remember this one. So let's discuss the further things here. Next, we will loop through the array. So here we'll be performing the XOR operation, right? So we'll be performing the XOR operation here. Just give me a second. Did I do anything wrong here? No, right? So this is fine. So first we have here as 303, right? So we have here as 303. First what we will do, 3 in binary is, first we will perform XOR for 3 and 0. 3 in binary is 0, 1, 1 and 0 in binary is nothing but 0, 0, 0. So we will perform XOR for 0, 1, 1, 0, 0, 0. In this case, XOR is when two digits are different, then only we get 1. Means either it has to be 1, 0 or 0, 1. Then only we get 1, else 0 0 1 1 will give us output 0 itself, right? So 0 0 0 1 0 1 1 0 1, so 1 0 1 1 we got. Again, now we got for 3 and 0 we got 0 1 1, right? So again, for 3 we have to consider 3 XOR 3. Now for these two we got 0 1 1. For 3 again it's 0 1 1 itself. 0 1 1 0 1 1 will be 0 0 0. So only if the numbers are different, then only it will be 1 for the XOR, right? So just remember this one. So now we have, for this one we have 0 0 0. In the integer, when we convert this one to integer, we get 0. So this is how we got 0 here in this case, right? Let's move on with the second one here, 3 XOR 3. So not this one, basically I'm speaking of this one, 0 1 0, this one. So this one, 0 1 0 XOR n equals 1 we have. So here in this case we went with 0 first. Now we have to go with 1. 0 1 0 we have. 0 1 0 means 0, for 0 it is 0 0 0. For 1 it is this one, 0 0 1 basically, right? So the output here, the answer will be 0 0 1 itself, right? 0, when only two numbers are different, then only it is 1 for XOR. So this is fine. So 0 0 1, again here we have to go with this one, right? For this one we got output 0 0 1. For basically now it is 0 0 1 0 0 0. 0 is 0 0 0, right? So again this will be 0 0 0 1 itself. 0 0 1, and when we convert this one to integer, we get the output 1 here in this case. So that's what we got here, 0 1 we got, right? So here in this case XOR 2 XOR 1 will be performing, basically 1 XOR 2 XOR 1. So 1 will be 0 0 1 and 2 will be, in this case 2 in binary is 0 1 0 and 1 again 0 0 1. So first let's go with 1 XOR 2. This one will be 1 1 0. So 0 1 1 we got. Next 1 0 0 1. So 1 1 is 0, 1 0 is 1, 0 0 is 0. So this one 0 1 0 we got total. When we XOR, first we will go with 1 XOR 2. Next we will go with the number that we got in the binary representation XOR 1, right? So overall output that we got is 0 1 0. 0 1 0 when converted to integer is nothing but 2 here in this case, right? So this one, the last integer whatever we got, this one we will return this one as output basically. So the output that we got here is 2, right? Which is equivalent to the output that they have given for the example one in the question. So the approach works absolutely correct in this case. Now as we are completely familiar with the approach, let's start writing the code. So the first step here is we have to get the length of the array. Means the range is, in this case for the first example, the range was 0 to 3. This one I'm speaking of. First we have to get the length of the array. So we'll be making use of the length of the nums so many times. So I'll just initialize that one to the variable, some variable. I'll just go with int n equals length of the nums. This is fine. So the next step is we have to initialize XOR with n. Means because index only goes till n minus 1, right? That is the reason we'll initialize the XOR with n here in this case. I'll just go with XOR equals n. This is fine. We have assigned basically XOR to n. So this is fine. Next, let's traverse through the all the elements in the array. So I equals 0, I less than n plus. This is fine. Within the for loop, what we will do, we will XOR both index and element with the current XOR. So we have done the same thing in the approach. So we'll write the exact same thing here as well. So here I'll just go with equals I, this one XOR nums of I. So this one we have solved using the same thing, performing the XOR operations every step. I have showed for the first example by considering the first example 0 1 2 how we got, and finally we return 2 as the output, right? So this is what we have articulated, same thing in the form of code here, right? So the final step here is we have to return the XOR value that gives the missing number. We are returning the final XOR value which gives the missing number. Basically in this case it is return XOR. This is fine. So let me format the code once and let me hit the run button. So here you can clearly see the sample test cases are getting passed. Means the code works absolutely correct on this case, right? So the sample test cases are getting passed. So the code works absolutely correct on this case. So let me hit the submit button quickly. So here you can clearly see all the test cases are getting passed. Means the code works absolutely correct on this case. So let's quickly discuss the complexities for the code that we have written, right? So the approach that we went with here is this one, XOR based index value cancellation, or you can just call it as XOR based, right? So overall time complexity would be big of n here. Why it is big of n? Because we are looping once through the array. This is linear time. I'm speaking of the line number 6. You can clearly see here, right? So we are looping through the array exactly once, nothing but linear time. So the time complexity would be big of n. So what would be the space complexity here? The overall space complexity would be big of 1. Why it is big of 1 here? Because we are making use of constant number of variables n XOR. Here this I'm speaking of line number 3 and line number 4, n and XOR. This basically uses only constant space, right? So overall space complexity would be big of 1 in this case. So the time complexity for the code that we have written is big of n, and the space complexity is big of 1, right? I hope the complexities are completely clear, and I hope whatever the code that we have written is completely clear. For now, this is it. Thanks for watching, guys.